Good day, grade 11 STEM students. Welcome to the HP classroom. This video is the second example of proving divisibility statements using mathematical induction. So we need to prove that 4 raised to 2n minus 1 is divisible by 5 for all positive integers. So we have put this in the function f of n is equal to 4 raised to 2n minus 1. For the first step, we will use verification. So we need to verify that f of n is equal to 4 raised to 2n minus 1 is divisible by 5 when the value of n is equal to 1. So we have n equals 1. Let's copy the function. So we have f of n is equal to 4 raised to 2n minus 1. Replace n with 1, so we have f of 1 equals 4 raised to 2 times 1 minus 1. So our f of 1 is equal to 4 squared is 16. 16 minus 1 is equal to 15. And as we all know, 15 is divisible by 5. After we have verified that it is divisible by 5 for n is equal to 1, we need to do the hypothesis. So for hypothesis, we will replace the value of n into k. So we have n is equal to k. Then replace our function. We have f of k equals 4 raised to 2k minus 1. And 4 raised to 2k minus 1 is divisible by 5. So we hypothesize that this function is divisible by 5. Next step is assumption. We need to assume that f of n is equal to 4 raised to 2n minus 1 is divisible by 5 when n is equal to k plus 1. So we will change the function or the value of n of the function to k plus 1. So we have f of k plus 1 equals 4 raised to 2 times k plus 1 minus 1. So after the first 3 steps, we are now ready to prove. So we will just simplify. So we have 4 raised to 2k plus 2 minus 1. We are now ready to prove. For proving, we will need the values we get from f of k and f of k plus 1 by using this equation, f of k plus 1 minus f of k. So again, first we need to write the value for f of k plus 1, then subtract it by the value for f of k. Let's copy. 4 raised to 2k plus 2 minus 1, then subtract it by 4 raised to 2k minus 1. So let's copy first. We need to distribute the negative sign. So we have 4 raised to 2k plus 2 minus 1. We have negative 4 raised to 2k and positive 1. We can observe that we have, by adding like terms, negative 1 and positive 1 will be 0, and we are left with 4 raised to 2k plus 2 minus 4 raised to 2k. We need to manipulate these terms in order for us to prove the function. As you remember from our mathematical induction, we can factor out this exponent. Using laws of exponent, we can say that we can factor it out by 4 raised to 2k times, we need to factor out the constant with the same base, so we have 4 raised to 2. Then copy the remaining terms, negative 4 raised to 2k. So we have 4 raised to 2k times 16. So 4 squared is 16 minus 4 raised to 2k. We can observe that there is a common factor for these terms, so we need to factor out the common term or common factor. This is for reminder. So what is the common factor? Here the common factor is 4 raised to 2k. After factoring, we have 4 raised to 2k times 16 minus 1. Let's evaluate 16 minus 1. So we have 15. So 4 raised to 2k times 15. At this point, we need to factor out 15 with 5 in it. So we have 5 times 3 times 4 raised to 2k. Then, we need to multiply 3 by 4 raised to 2k to simplify. And our answer is 5 times 12 raised to 2k, wherein 5 is divisible by 5 for all positive integers. So our next step is the divisibility test. For this divisibility test, we need to use the values we get from f of k plus 1 minus f of k and balancing it out by adding f of k to both sides of the equation. So our answer is 5 times 12 raised to 2k plus f of k. So let's substitute f of k. So we have 5 times 12 raised to 2k plus 4 raised to 2k. Okay, we will repeat this. 4 raised to 2k minus 1. And our answer is 5 times 12 raised to 2k plus 4 raised to 2k minus 1, and 5 is divisible by 5. So we can conclude that f of n, which is 4 raised to 2n minus 1, is divisible by 5 for all positive integers. That's it for the second example of mathematical induction.